Welcome back to design patterns, Python design patterns for GCSE and beyond and even before. You may have seen my video about type validation. This is the sort of concise version where you test, you initialize your variable that you're going to input into something invalid as far as your criteria for validity. Here our criteria for validity are an integer between 1 and 6 inclusive. And whilst it doesn't meet, so it's smaller than 1 or it's larger than 6, we will ask for a number. Notice the caret, that's a nice touch. It's not a caret actually, it's a greater than angly bracket. Consoles look like that. Equal 1, why not? It sort of indicates that computer has finished typing, now it's time for the user. There's going to be a blinking cursor next to it, which looks pretty nice and old school. And then I've not touched on this in my video on input validation, but you would have, I'm sure, complemented yourself. Then simply if your input was not valid, you can, in the while loop, because this is also something we're going to want to happen every time, check for invalidity. So if it's not a number that is greater than or equal to 1, and a number that is smaller than or equal to 6, aka a number between 1 and 6, we're going to print an error message, right? The problem you have, so this runs well. Number, no, 0. How about 7? Down the raise, 6, your number was 6. Notice the F string, I might make a little separate video about it, but this is now the most elegant way of displaying a mix of your own copy, string, and contents of your variable, potentially formatted in various ways, as of Python 3, or maybe 3.10, as of the latest the version at this the time of recording. So this works very well, except that if I enter something that doesn't cast to an integer, so we're nesting int, which will cast to an int, and input. So if I enter a string, boom, big, ugly red error. Well, let's make that a bit bigger. So how do we deal with this? We get something that's not castable to a string. Well, this is where we introduce the try except syntax structures that allows you exception handling. So this is an exception. It's a value error. This has been thrown when the function int has encountered an input that it couldn't turn into an integer. So what we're going to do is we're going to wrap the line that may break. So if you know, oh, this is a possible error that can happen, and this is this value error. So we're going to say try colon, it's a code block, you indent it, except so this will attempt to run this line. So if you had done it in 2 line, like if you had num equal input number, I can just drag and drop, right? If you have like a line, I can't drag and drop, so maybe not. If you had a line for the input with the bracket, and then you would cast this to an int, it's only the forgive me, it's only the casting line, the line where we call int. Let's just we need something over the parser, which is a parser, the thing that parses the text to see whether it's valid, is not highlighting this error. So if you're doing in 2 parts, it's only this line that's liable to throw a value error. So you'll want to move this out, right? So your try block should contain as few lines as possible. And here, so what's happened here? Well, except pass that should work in that if the value, well, let's just try it. Number 1 will work, obviously. -1 will give me the error message, and if I say string, so we then have this problem that because we've done it in 2 bits, we have this. If I actually put this back in here, it should now work, because num will never take a string value, because if it had, we would have accepted, and because that will means we've not run that line, which means we've not run the assignment of or cast attempt, because there was no cast attempt into num. So num would then be whatever it was before, which is the first time it's liable to be -1, or whatever number that's not between 1 and 6 was entered before. Whereas if we do it in 2 bits, on 2 parts, then num can take that string value, and that breaks this. Whereas in here, this will work, and having a simple except pass will throw an error message, right? However, you may stop here. That's the basic, that's the basic thing. So new chapter and 908. Making a quick note here, because it's nice to label the video for the YouTubes. Okay, which if they jump to the chapter are going to be glad. Right, if we want to get a little bit fancier, let's say, okay, we want to defend against string. This is what we call it defensive programming, right? You can foresee what errors the user is likely to bring to your lovely code that was so perfect until it was ran and used, and you defend against them. So we're defending against string very well, but this, that's a string of a real number, to be fair, so that can't be casted to an int. Yeah, this is not what I want. This is not what I wanted to show. I apologize, because it's still a string. I thought that this would actually cast to an int. I'm mistaken, and that we could like try and do a separate except. Let's say, for instance, okay, we want to be a bit fancier. In here, we might print a different error message. This was not a number. Exclamation mark. When you start throwing exclamation marks at the user, it's just a bit mean. But then, because we don't want this to then fall back, and that case to be here, we're not going to break out of the loop. So you might know the break command. We are going to continue. Breaks out of the loop, continue, we'll just skip whatever is the rest of the loop and just go to the start of the next iteration. So now, string, this was not a number. And then if I put 0, and then if I put 2. Now this is the first thing. Okay, a separate point. What time is it?